Yeah, as one does.
Yeah.
Okay. It is 12:07. If you can get your notebooks out and your notes out. We are ready to rock and roll. We first have to start off with attendance, unfortunately. And so, Timmy, not here. Ben, not here. Jonathan should not be here. Ariel? Zoe? Lisa? Felix? Zane? Matthew? William? Alejandra? Birdie should not be here. Okay. Zachary? Kieran? And then William should not be here. Naomi? William's here? What? Okay. Naomi? Hugo? And Sahir. Sahir should not be here. Dun, 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 dun. That's a lot of people who's not here. I'm probably going to have to record that in another way as well. What? Is that the wrong one? Where's the right one? Where'd my phone go? E minus. E minus, yeah. Yeah.
So I only know the middle part of the island is the Noyo.
Sorry, what?
The Noyo. Like the middle of the island. What is it called in English?
Neons? Gluons?
The middle of the island is the middle.
Nucleus.
Yeah, I don't know his Noyos.
Oh, interesting. You were what?
I've never taken any classes in French. Yeah. Mr. Newfield?
Yeah.
I think my bullshit must have felt of my blinders class.
One second. I'm just quickly double checking attendance because something came up. I will not be paying attention for a whole second. Jesus, stop doing that. Okay. Akin's not here. No, Timmy's not here. There we go. And Ben's not here. Jonathan's not here. And then Birdie's not here. William's not here. Hold on, which William's not here? William Wren's not here. And Sahir's not here. Yo.
Isn't it like uniform is like a long sleeve white shirt?
Yeah, technically.
Oh, okay.
Yeah.
So basically.
Not for staff.
Oh.
Yeah. We have a whole different uniform. So, like business dress. It's more, it's less well defined as your uniform. Okay, we can get rid of that. And we can start on here. Where's the random? There we go. Okay, notebooks out. Notes. Karen, I'm thinking I may have to move that section. You're very, very talkative. Know each other quite well. Although you may also cooperate more, so we'll have to see. I should have just had you do this while I was getting things ready. Fill in this table. You know this from last year. What is the symbol for each one of these? What is the charge? What is the mass? And where is the location? I will ask people at random to give me what their answers are in about a minute. Apologies. I should have started with that while I was getting the live stream going.
Yeah, Mr.
careful.
Yes,
I
question.
don't know why I got the first page but broken and the other pages I didn't have it.
You don't,
I had the whole Spanish but maybe it fell from my blind.
check in the back. There's one back there.
Oh, okay. That's yeah. Yeah. No, I'm very. Yeah.
Oh yeah.
There you go.
Electron. It would be.
It's neutron.
We went over it the other day. Wasn't the debate shell? But it was one of the other ones. Electron shells.
Okay. Let's random pick this. It's picking Naomi. What is the symbol for an electron? E. Anything else?
And then like a negative.
A little negative, yeah. And the reason for that, why we put the charges with all of these, is because these symbols are also used in other areas. So an E in math actually has a specific different meaning. And we don't want to confuse the two. Random. Ariel.
P positive.
Be positive. And let's go with Alejandra. And now, cleverly, you didn't put a charge. This is one of the few in which it is sometimes omitted. If it was to have a symbol there, what would it be? Do you know? No, the person. Zero. You threw your voice to the front very well. That was excellent. Lisa, give me all the charges.
Electron is a -1, proton is +1, and neutron is 0.
Neutron is 0. And let's go with Zoe. The mass of any one of these. Where's Zoe? There we go.
Anything, everything?
Pardon?
Anything?
You can pick any one of them to answer the mass for.
Oh no.
I'll give you a hint. You only have two choices, 0 or 1. So a proton weighs 1. Well done. And now AMU, might want to make a note of, this stands for atomic mass unit. It is very small. You take this amount in decimals at 6.022, and sign of notation would be 6.02 times 10 to the 23rd. AMUs equals exactly 1 gram. So it's a very small amount, but a proton weighs the same amount of that. So, Zach.
For the neutron, 1.008665.
Nope, it's just 1.
Yeah, I know, but that's
Nope. We do not include those because, tell me the mass of an electron.
It should. You would write it as 0.
I'd write it at 0.
But it is 0.00.
No.
54597.
No, it is 0. Now, you are correct. A neutron basically weighs about a little bit more than a proton plus an electron. And an electron weighs a very, very scattered amount. For most intents that we will use these for, and you'll use them for all the way up to university, you can treat them as 1, 1, and 0. Proton weighs the same amount as neutron. It's like if you're weighing a dump truck at the dump, and you're like, it drives in, it weighs 5.6 tons, and you're worried about the flies landing on and off of it. The flies are like the electrons. They don't matter. And so we say those are approximately 0. They do have mass, though, so they can't go the speed of light, and they can't do other things that have mass do, but
Well,
technically
actually
correct.
speaking, a neutron is.
Are you well actually me? But yeah, so for this, we're going to treat them, protons and neutrons are the same. And we're just going to add them up by counting. Location for these, let's go with... No, I'm going to pick someone at random. And it's picking Hugo.
No, so electrons are in the shell, proton in the nucleus, and neutron in the nucleus.
nucleus. And the nucleus. Excellent. Next up, I want you to draw in here a model of boron. What did the miner say to the other miner?
What?
Boron.
That was.
Huh? Not all of you are smiling. I want you to label the electron shells, electron energy levels, the outermost shell, the valence shell, the valence electrons, the inner electrons, the inner energy levels, and the nucleus. I highly recommend you do not draw this to scale. If you were to draw it to scale, let's say I made this the nucleus.
That's too big.
That's way too big. Let's say I made, still too big. Say I made that, no, let's do that. Let's do that. Still too big. There. I make that the nucleus. By scale, the nearest electron would be about
Bro, just keeps going.
Actually,
Sorry. I've just run 2 football fields length away and back. And on a tree that way, there's a very tiny dot. Thank you.
Get it to run it.
So you are allowed to squish it in by a fair amount. Drawing it to scale would be insane. But do boron and do a atom of boron, not an ion of boron. If you've done that before.
what if you do both?
You can do both. Pardon? But I don't want. Why did you ask if you could? If you're not going to. That feels like just setting up for a
That's
conflict.
why I wanted to sound smart, but I just don't want to do it.
Yep. Oh no, you're gonna check it. Yep. I'm just gonna give you a couple minutes to draw it and label it. You can confer, and then I'm gonna have everybody get into like groups of 2 or 3 and draw them on the board so I can double check that everybody's not missing something. And then we'll draw it here on the board again. It is review, but I want to make sure we have it. We only really need 2 people. Yeah.
Do we have to label the ball?
You have to label all those parts.
Oh.
Aren't they the same? The outer
Oh, yeah, some of them refer to the same things, but I want to know that you know what they are.
Yeah.
Yeah. Find coordinate point P. It looks like someone was doing math here. How dare they? Also, I found out if you happen to wear kilts, if you take them to any tailor, it is really easy to put pockets in them. I've got pocket here, pocket here. This one's not as easy to get tailored on, but also a pocket in the front that's hidden. So I've got 3 spots for my cell phone.
Or for our time.
Pardon? No, none for your cell
I
phone.
think you should do
Zane's cell phone?
Yeah.
Is Zane have a cell phone up?
I don't know. I think you're on it.
I feel like it. I can just
I'm
feel
currently looking at my cell phone. I'm currently.
Zane, I'm really disappointed. Okay, find your person, go up and pick a spot on the board and draw it and label all the parts so that you can double check each other. And then that way I can quickly go around and double check.
Hey, wait.
Okay.
Find your people.
It shows it as a shell. I'm not too sure.
Oh, wait.
Yeah, we do. That was daily time.
Yeah. Do you want to go? Do it with me?
On the board.
Shell is the last one,
Oh.
right?
On the board. On a whiteboard. Grab it. There's whiteboard pens up there.
Felix?
We're on 5. 11.
No, it's not wrong. It's how we're supposed to do it.
There's more whiteboard pens over here if those are dry.
Like Rick said.
Did anybody come in late and not get assigned to it?
Here, you pass
not
it
get
to
on your
me.
other table? No, we're
We're
out.
on and we'll start later.
Oh, where'd my pen go? There it is. Nucleus, valence electrons, inner electrons. Are those together? Oh, right, I just got my arrows confused. Valence shell and, your lines crossed at one point, I just drifted the wrong way. Good, valence shell, inner shell. Energy level, we got the nucleus. I think that is all good, I don't think we're missing anything. Valence electrons. How many electrons in your outer shell? Okay, I don't see it yet. Live. I don't know if you're, there you go. I normally check with other groups with some of your names. No, the labeling. Your labeling looks good. We got valence electrons, valence shell, inner electrons. Where's the nucleus? With the inner energy level. Ooh. You don't want to check some of those labeling. Inner energy level. Yeah, don't do that. I mean, this is one of those. I'm referring to the electrons because you don't know about nucleus energy levels. They technically exist. We're not going to discuss them.
Okay, what else are we missing?
How about you guys? Did you guys figure out? Where's the valence? Excellent. Okay.
Oh yeah, I did the right. You said
Okay. Once you're done, you can have a seat back down.
okay, you're the only one that is yours. Actually yours. Actually yours.
What? Fun fact. A in Old English is sorry.
Wait, what's wrong with the book?
Okay. Um, so one of this is just getting used to the fact that you pretty much call electrons almost anything you want. They're the shells, they're the energy levels. You have innermost shells and you have outermost shell. The outermost shell is also the valence shell. It's called the valence shell because that's where the magic happens. So that's where the electrons do things. If you take away the electrons, that doesn't magically become the valence shell. That's a core. These are also known, I don't think I actually asked you to label it, but a term you'll learn in Chem 11 would be these are the core electrons, and they don't move. They're too tightly held, and they will not participate in chemistry. And so the valence shell is the shell that participates in chemistry. The noble gases are, of course, called the noble gases because their electrons, it's debatable whether they have valence electrons or not because they have full shells. However, researchers at the University of British Columbia won a Nobel Prize because they got xenon. They're the first researchers, this is ages ago now, like 80s, 70s. They were the first ones to form a compound with xenon. And like most things, they did it by cheating. They first built a molecular box out of atoms and trapped the xenon in the middle so it couldn't leave. And then they were able to prove that it was undergoing some weak bonding with it because it couldn't go anywhere, so might as well. And since then, we've built a few other things, but they really don't like to. Okay. We've reviewed Bohr model, not to scale because the nucleus is 10,000 times smaller than the size of the atom. Most of things are empty space. You've probably heard of that before, that if it is really a miracle that I can't just take my hand, push it down, and then just phase right through the table. Because if the nucleus is 10,000 times smaller than the atom, it is a tiny dot in the middle of empty space. The electrons are basically nothing. They weigh nothing. All the mass is in it. And so the empty space of my fingers and the empty space of the table should just pass right through each other. If I was to take our really bad model over here, my really bad model right there, ideally, now make it to scale. So to make it to scale, put these a lot farther out, make this group a lot smaller. And this is still not to scale. But it should be fairly easy for this nucleus to bypass that one and just go straight through. Does anybody know why it does not? See. There is a field. What kind of field? Pardon? The atomic is the name for atom. So you are correct, but what is the atomic field? Like, why don't we phase through, Kieran? It's not magnetic. Magnetic is very rare. It's a property of metals. Which metals?
Magnetic metals.
Is iron magnetic?
No.
Yeah, that's one of the main ones.
Yeah.
Yeah, if you have iron, it sticks to it. It's iron, nickel, and cobalt, and that's basically it. All the ones you'll ever encounter. And it's really nickel and iron is all you're going to see. Pardon?
For most metals, if you just heat it up, and then as it's cooling, if you have a magnet to it, it'll attract, you can form with most metals another magnet.
No.
Doesn't it?
Copper won't do that. Copper's like crazy. Now, if you take copper and you make a wire, any metal you run electricity through it, you can make a magnet, but that's using the electricity and other things. Most metals are not magnetic. So magnetic fields are actually kind of uncommon. Now, there are other weird states of magnetism that you can generate and force things to have. Oxygen becomes magnetic in a really weird state. But this is a long way to say that it's not magnetism. I just realized. What are the only forces here?
Attraction.
Electrons. Pardon?
Isn't like positive and negative?
Right. Yeah. So positive and negative attract. But will these positives and negatives ever see each other?
No, because the field
No.
around them makes sense.
Yeah. Because these, of course, go all the way around. So what's happening is these electrons are repelling those electrons. And so they just repel away. The empty space is there, but it's just a repulsion. So when you're touching something, if you take this and you're like pushing down on the desk, you're not actually touching it. It's just the electrons repelling the other electrons, like magnets hovering over each other. And that's all that is. If you got small enough, you would see that there's empty space between them. And that's why atoms don't phase through other atoms. If it did, we'd all be sinking into the floor right now.
Question then.
Yeah?
If something has, let's say, more shells, if they have more electrons,
Yeah?
then would there be less friction because it would keep it farther apart?
If they have more shells, there's more repulsion. Now, even a very simple atom, like hydrogen with one electron, will have that repulsion. But if you want to like fire atoms through another set of atoms, there's famous experiments like the gold leaf experiment. Gold is used because you can pound gold to like 3 atoms thick, and then we'd fire helium at it and see whether they bounce back. And some of them will just pass through. It's thin enough, and there's so few enough that they actually can get through sometimes because of the amount of
So
space.
then theoretically, if you get lucky enough, you could just like
Yeah.
pass through.
You can actually, with quantum chemistry, calculate the chance of your hand phasing through. There is a chance. It's really low, like astronomically low, like the chance of it happening multiple times of the universe have to happen. But there's a chance.
It's like 1 in quadrillion to like 17.
Yeah. It's like the chance of, well, I won't say it. Yes.
Isn't that the Rutherford experiment? Like
The Rutherford experiment is the one with the gold leaf. Yeah. And that found out that the nucleus actually is small and dense. Oh, and I won't say that one either. And I would like you to add to this one, because every time I think of something, it's inner house, and that gets annoying. Like, it's small and dense, like, the boys from Roger's house. It just, I shouldn't be doing that all the time.
I'm the only Rogers in here.
Yeah.
Small.
So, you mentioned it, so I had, anyway.
Leave.
I'm just messing with you, by the way.
No, I think everybody can agree, if any house wins inner house this year, Rogers would deserve it.
Yeah.
Rogers needs to win.
Why?
Yeah,
When's the last time they won?
Never.
19.
They haven't won since I've been here.
How long have you been here for?
I've been here since 1999.
Oh, we haven't won in 20
Yeah.
years. Yo, really?
Yeah.
Well, this year is gonna be
The
different.
Zura is going to be different.
This year is gonna be different.
Different.
Guys. You guys are already in first place.
No. Just so you're aware, cooperation happens between houses. Ellis won for like 4 or 5 years in a row. So between Rogers and Whittle and Privet, they were like Privet was number 2, so we got to beat Ellis this year. And so what they would do is they would make sure that their players would go up against the right Privet players, so that Privet player would either win or lose, such that our best players went up against the worst Ellis players to ensure that we beat Ellis, to make sure that their points went down as ours went up. It was a full 3-house cooperation to do that after you won. When you win a few years in a row, everybody bands together to take you down. You can't have that. So it's perfectly fine if someone else, after a number of time, gets lifted up. I think that'd be good. Get out your new periodic table and label what these are. What are those? Notice it says Snowium. That's after Mr. Snow, because it'd be a little arrogant to put Neufeldium. But I will say that there's a long, time-honored tradition in the field of chemistry. If you discover a brand new element, you're allowed to name it. And the longest tradition is that if you name a new element, you are required to name it after your grade 10 chemistry teacher.
Really?
Are you technically allowed to name it whatever you want? Mr. Neufeld?
No,
Neufeldium.
the International Union of Pure and Applied Chemistry has to agree. But there's there was one named after Berkeley, although they did get rid of that at one point. So they've had ones just named after schools. Berkeleyum, Californium, but of course Einsteinium, Mendelevium, Nobelium. There's ones named after
So you
people.
can't just spend your entire life trying to create a new or find a new atom and then name it the most silly thing.
Well, in biology, there's more things to name. To name an element doesn't come up as often. So you have a bit of leeway. But for example, all the big stuff has been named, like zebra and elephant. But if you're just, we discover new creatures all the time, little tiny ones. So there's a person who specializes in mosquitoes.
Oh god.
And he named them all the different species he was discovering had a Latin root that ended like that. You pronounce it, kiss me. And so his mosquitoes are named Polly kiss me, Molly kiss me, Sandra kiss me, because they're all blood-sucking mosquitoes. And they kiss you.
Do you have any faith that any of us will find the element?
I have complete and utter faith.
I'll find it.
Complete faith. I want one from everybody.
Yeah.
Okay. I am going. No, I put down my pen. And top number, please, Matthew.
What?
What's the top number?
Atomic number.
Atomic number. And what is the atomic number? Nope, I've asked you like 3 times. Nope. Number of protons. So that is the number of protons. And ask random. William. William K.
The symbol.
That's the symbol.
It's a color.
Now, the symbol is, I've given it SW. How do you have to write the symbol? No, William.
Like the first one has to be a capital, and the second one has to be a lowercase if there's a second one.
Yeah, uppercase, lowercase. Does anybody know where the terms uppercase and lowercase come from? What? It comes from typesetting. So when they have newspapers, you would actually get metal blocks in the shape of the letter, and all the capitals were up high, and all the and closer because you had more. You would use lowercase more often. Were lower down, and so you literally had the uppercase and the lowercase of letters. You have to do it that way because if you do it something different and you get confused, you can kill somebody. So this. Yeah, it's a terrible pen. That is carbon monoxide, a deadly poisonous gas. It's a compound made of 2 elements, carbon and oxygen. That's a metal. You could get heavy metal poisoning from it, but not very likely unless you breathe it in powdered form. And oh my God, it's toxic. But just a solid piece of cobalt is relatively safe. It's not going to kill you instantly and requires completely different safety handling. I don't know what that is, but you're probably going to think it's carbon monoxide. So if you have something like, does anybody know what element that is? That is mercury. If you want to memorize it, that's mercury. Mercury is a heavy guy. It's a liquid metal. This is correct for mercury. This is, of course, incorrect. But this is also incorrect. Because what is that? Is that uppercase, lowercase? It's uppercase, but you wrote it small. We want to make sure there's no ambiguity because we want to make sure we're not accidentally poisoning ourselves. So it may seem like I'm making a big point out of it, but the number of students who will write down, let's pick a very common one. Bromine is a common one. I see a number of students who will do this and write like a little R or something like that, and it's like, okay, I know you made it small, but that's boron. That may be the start of radium. The only thing that is bromine is that. And so you do have to do your symbols correctly. My lecture on that part is now over.
Just so nobody dies.
Just so nobody dies.
Yeah.
I only care about spelling when it comes to chemical compounds. And then, of course, that one I think we know. This is the name. Both aluminum and aluminium is correct, and both sulfate and sulfur with both an F and a PH is correct. It depends if you're in the UK or in America and Canada, because we're very confused. Do both. Hand? Oh, I'm calling people randomly. But you just said it, so now I'll do it. This is the atomic mass. What is the atomic mass? Yes? No, I've already asked you. And I've already asked. Who have I not? No, I've asked over here. Have you answered anything? I have not. What is the atomic mass? Do you remember? You also may have been avoiding the question, so that may not be fair. What's the atomic mass?
I don't know.
Yes?
Protons plus the neutrons.
I'm so glad. I'm waiting for someone to say that because it's wrong. However, it is approximately equal to the protons plus neutrons, but not really. But that is practically what you're going to do with it. And the reason is because it's the average of all isotopes of protons plus neutrons. And so we would say 517.4, well, it's really 517, and that's rough. But in some cases, it's literally untrue in the sense that I can't remember if bromine is one of them. I think it is. I think bromine is the one in which there is bromine 81, and there's bromine 79, and the average comes out to 79.9. There is no bromine 80. It just doesn't exist. So these averages can lie. But we use them as a rough approximation at some point, but I don't want you to confuse them. I think I said this the other day. If in Canada, I believe it's 1.7 children per family, and even if you get an arm and a leg cut off, you're still a whole person. You can only have like a whole person in a family. So each individual family has like 2 children, 1 children, 3 children, or in the case of my grandparents, 14 children. Families a few generations ago had more children because infant mortality rates were higher. I'll get your question in 1 second. However, if I ask you for the number of neutrons and you do an estimate and you minus and you give me a decimal, that is wrong because you can't have part of a neutron just like you can't have part of a person. Yes?
So, 2 things now.
2 things?
For when you like subtract it from the atomic mass to find like the number
Neutrons?
of neutrons, do you round up or like do you just round to the nearest number?
You round intelligently.
So if it's 5,
And then
you round
also,
up.
could you get the computer to translate your writing? Because I can't read like the yellow
What?
part.
Okay, I will do that. Now, if it's 5 and above, round up, and if it's 4 and below, round down, is the like grade 10, 11, 12. If you go into engineering, they actually have a further rule, because if it's 0.5, you actually don't round up in engineering. You also don't round down, you go 1 more decimal. So if it's 517.54, you'd round up. If it's 517.59, you'd round down. I think I've got it the right way, because they just look at the next number. If it's even, you round up, and if it's odd, you round down. And the reason they do that is because 0.5 is literally in the middle. If you consistently round up, you will introduce a consistent error. And if you're introducing consistent error, that's how bridges fall down. So they want to make sure that the error they're introducing cancels each other out. You don't have to worry about that, but it's kind of cool to know that people who build our skyscrapers have to worry about that amount of accuracy. Question?
No, I was.
Oh, I thought I'd flicker of a hand. Okay, and you wanted to know what I wrote. If the computer can read it, I am going to mock you. And the computer couldn't read it.
Julia Aurora Proton FPTA.
Okay. Average of all isotopes of protons plus neutrons. Oh, my God, that's not even close.
So we get to mock you now?
Oh, totally. Average of all isotopes of their protons plus neutrons. So it is an average. And this is one area that if you're ever taught previous to this by someone who wasn't a chemist, they might have just told you it was a protons plus neutrons. That's fine. Not everybody's a chemist when they teach. It's like,
Are you Kevin?
yeah, my background is chemistry and biochemistry. I did a minor in biology as well. Well, I didn't get a minor. I did some courses in it. By the time I graduated, I had enough for a double major in biochemistry. You end up doing a lot of biology in that as well. If you were taught previously, one of the reasons why some of these things go on and that they're not defined is because they're not specialists. Guess where you find the highest number of teachers with math phobia? No, not in science classes. I mean, maybe. I don't know. It depends. No, not English. Not math, not socials. It's not an area. Elementary school. Elementary school has the highest percentage of teachers with math phobia. And they're teaching our youngest children math. And sometimes people come out thinking, well, math must be hard. I told you guys the other day, oh no, I told science and ethics. I didn't tell you. Some of you were there. If I tell you that you're not very good at something as a teacher, you have an IEP, it's really difficult, whatever, you are more likely to do worse just because you believe that now because I said it. And if I tell you it's really easy and you're going to be good at it, you're more likely to do well. If you have teachers who consistently believe that a subject is hard or they themselves have a phobia of it, it's not as taught as well in the junior grades. So if you think, oh, I'm not doing very well at math, you're actually awesome at math. Just blame your teachers. Those mean, evil kindergarten teachers. They're terrible people. Okay. Neutral atoms. What does the word neutral mean in terms of charge?
Neither positive or negative.
Yeah. So there's no overall charge. The number of
Electrons.
an electron that counts. Whoa, atomic number. I think. Oh, I skipped down a line.
Yeah.
The number of electrons equals the number of protons for a neutral atom. And they had not. We've already defined these, so I'm just going to fill them in. Atomic number, a whole number. What are whole numbers?
A number without a decimal.
A number without a decimal. Yeah. Okay. That counts the number of protons.
It says and. Shouldn't it start with like a noun and
And whole number. I'm just going to go with that.
Wouldn't it be and then time?
It's interesting if you have an H. Sometimes you have to use an, and sometimes you have to use a. It's a house, but it's an hour. Does anybody know why? Yeah.
Because English is stupid.
It's because English is not defined but necessarily by writing, but by how it's pronounced. So an hour starts not with an H, but with the O. So it sounds like a vowel, so you use an. That's the English rule. There is no specific rule for H that use an or a. It depends on how it sounds. But if you say house, you use a house. That sounded like I was about to say something else. And all atoms of the same element have the same atomic number of protons. A mass number is also an whole number, just to be irritating. That counts the number of protons plus the number of neutrons in the nucleus. This is not an average, and it is specific to an atom.
We're free.
Wait, isn't this early?
12:50. No, this is dead on time. Classes don't end at 1:15 on Saturdays. They end at 12:50, and then
We're in grade
shortened
10.
classes.
1 o'clock.
What?
We're in grade 10. 1 o'clock has a late class.
Yeah, but on Saturday it's still 12:50.
Oh, yeah.
There is no early lunch on a Saturday.
Oh, okay.
Yeah.
But no, you said that we were 1:15.
Oh, that's right. Yes.
See, we're
Yeah,
special.
junior classes.